Okay, so welcome everyone. Good to see some familiar folks in the audience. But so this is IDS 594, which is MLOps. You can call it machine learning engineering or operationalizing machine learning. There's several informal names. So in case you're in the wrong course or link, there's just a quick, check. Okay, so welcome. So I'll get started with some logistics first, and then we'll get into the content of this lecture. So my name is Teja. I think some of you have taken my course previously, and some may be taking now. So good to see all of you. Let me get started with some basic, I guess, Zoom considerations. It's entirely optional for you to keep your camera on. I know some other courses may require you to keep your camera on. When you have a question or a comment, just unmute yourself and discuss. You can also use Zoom chat feature to add some comment, and then I can synchronously pick it up and discuss. It's gonna be recorded. I assume it's recording. Yeah, it's gonna be recorded. So in case you want to go back and watch the video again, I think it should be automatically posted after the each lecture session. So in case you miss for some reason, you can also catch up that way. Okay, this is a 2-credit course. So let me just walk through the logistics right now. Okay, so first I want to quickly go over Blackboard. There's not much going on in Blackboard, and then I'll actually get to the main syllabus page. So on Blackboard, there are 5 links, which kind of the most important ones are the syllabus and the project upload page. Zoom, since most of you have already accessed Zoom now, I hope there is no issue. If any of your friends have registered late for this, they may ask you for the link. Please share it with them. So there are 5 links. Syllabus page just leads to, I guess, okay, I think I lost the editing here. Oh, the syllabus page lost the link to the course page. Okay. Okay, so that's the link, and it'll have most of the content and syllabus as it states on the link. The second link is announcements, and there you'll find the archive of, in case we send announcements to all of you through Blackboard, then you'll get an email, ideally, if I don't, for the default settings, and then that email will also be archived in the announcements link, so you can go back and look in case there's some instructions there. There's a third link which is related to a project upload, and you'll see in the course logistics that there's one component that needs to be worked on by you, and that's the third link is related to that. The fourth link is Zoom, and so this is a weekly meeting. It's a lecture session for 2.5 hours or so, and so you'll find a link there. And finally, there's a discussion board. It's just a feature in Blackboard. You can, I've set up a default forum, so in case if you want to use that, feel free to do so. So those are the 5 links. With that, let me actually go to the main syllabus page and discuss that. And as I said, on Zoom, you can use both your voice and chat to ask questions or add comments. It is getting recorded, so so if you have something completely not related to ideas, related to this course, we can take it offline or through email or some other channel. Okay. So as I said earlier, it's a 2-credit course, and it has a physical classroom, BH308. The instructor is myself, and I have and we know the lecture session, which is now Monday 6 to 8:30. The office hours are from 8:30 to 9:30, which is right after the meeting, so that in case we people can hang around and we can discuss about the course lectures during those hours. We have a TA for the course. His name is Saket. He's a PhD student in the department, and he has given me a couple of options for his office hours. I will post it on this right after this lecture. Okay. So with that, let me open the chat so I can see if there are any questions. So let me first talk about the objective of this course. Okay, so MLOps is a relatively new, bucket of tools and techniques that a business analyst / data scientist / ML engineer should know. And so it's relatively new in the sense that there are very few courses offered in several universities related to this, and definitely, in a business school, it's a little bit even more, rare. But the objective of this course is to complement all the other portfolio courses that you've been looking at. Okay, starting from machine learning or statistical modeling and methods, the 575 course, or the business data mining or 572 course, or even deep learning. Okay, so this course is mostly a hands-on semi-lab style course where you want to put these models or modeling techniques or any other other things that you've learned into a production environment. Okay, and so there are several considerations that go into doing this. And that's what this course is about. So really have models, it doesn't matter how you got to the model, and we don't care about model accuracies or diagnostics and so on. I mean, in the sense that there should be consideration certainly, but not is not of concern for what we're going to do in this course. This course, we kind of assume that we have a way to build a model, or we have already built a pre-built, a model, and we want to kind of figure out ways to help others use it by hosting it on a cloud machine or an on-premises machine, and also take care of other things like periodic model retraining, testing the model using an A/B testing framework, and things like that. Okay, so here's a very short list of keywords, and we're gonna get into each one of them through the course. But first, I just want to enumerate these words so that you have a sense of at least the keywords for now, and we're going to go through them a little bit more, as a context again in a couple of minutes. First is deploying machine learning models using web servers. Okay, so I know we, in some other courses you may be using different types of servers, for example, in databases and so on. So here, at least we'll try to play with some simple web servers in Python and try to expose our model to the world or to users that we care about. Okay, so and we'll use a pretty popular micro web framework called Flask to do so, and there are many options, but we'll start with Flask. The second bucket of topics that we look at is called containers. Okay, containers are not specific to machine learning. Containers is an idea in, I guess, modern software engineering to containerize, as in like isolate your application or service so that it works with other applications and services, and together they can serve a complex functionality to users. Okay, so we'll look at containers, and in particular a popular implementation called Docker, and also a popular open source implementation or container management system called Kubernetes. Okay, the third set of topics is related to model management. So this is more about logging a model, so when you train a model, there's a bunch of things that you do manually. For example, report performance on a test set, remember all these parameters that you chose, number of trees or the number of layers or the model weights and so on. They can all be logged in an automatic way using some packages. So we'll look at that. And also scheduling the training. Okay, so your data, so most of your projects and assignments previously were just batch data and train a model once, and then that's it, right? So here in realistic business settings, you may have to retrain your model, maybe every month, every week, maybe every day. And so there's this notion of a job, a workflow where new data comes, it is augmented with existing data, and then that data is used to maybe completely train a model from scratch, or to just improve a previously trained model. And then that model is again sent for to be served to users using web servers. Okay, and if there's a new model, you can also A/B test, as in like compare how the model is performing in real life, not on offline metrics, not on a held out test data, but in real life with real life users. How does it perform with respect to the previous version of the model or some other model? Okay. There is some intersection of this course. As I said, it's a semi-lab hands-on course. So there's some intersection with the big data course that some of you are taking or might have already taken. In particular, we're going to look at distributed data processing, using Apache Spark IDE. There's also a slightly different paradigm where these containers or services, like one service talking to another service, is not synchronous. Okay, so in the sense that it's what's called a streaming setup, where you consider data to be streaming and moving along through a network of services or computations, and you don't really think of data at rest. Of course, data is at rest at some places in a database or in a storage location and so on. But here you will really be thinking of, there's some service, let's say a model prediction service, which is taking feature vectors from a location and slowly making predictions. And there's some other service which is sending feature vectors to like an intermediate location, maybe at a faster rate, maybe at a slower rate, so that these two are somewhat decoupled in terms of their operation, except that somebody sends something and then somebody picks up something from some common location. Okay, so that's a streaming setup in an informal explanation of that. So we'll look at that as well. Okay, so that was not that brief, but it was a very quick overview of like few directions that we'll look at. In terms of logistics, we have a very short 7-week sequence actually, because one of the next Monday is off. So and so we only have about 6 lectures I see here. So we have only 6 lectures, and then the last lecture slot is reserved for some project presentations. So this course is pretty much evaluated on the project that you will work on, and I'm going to talk about that in a second. And it's preceded by all these lectures. Any questions? Okay, so all this, some of it may be new to some of you folks, and you're still trying to figure out what the course content is, and we're going to discuss that in a second throughout this lecture actually. But if you have questions, and if you don't understand some words that I'm using, and I know there's always going to be some gap, at least for some of you who are somewhat unfamiliar with some of the terminology I'm using, do interrupt and at least post a message on the chat so that I can pick up and clarify that. Okay. So it's a short course, so thanks for joining. It's a short course, so I hope it's going to be interesting to most of you. So the topics, as I said, I'll not go through this whole list, but today we're going to be covering chapter 1 or module 1, which is about serving machine learning models using web servers. Okay? And it's actually a very gentle introduction. Hopefully people already have the prereq, which is exposure to Python. That's the only prereq. Exposure to some programming language is definitely necessary, and exposure to Python would be really good already. So there is actually a book which is listed in the section 4. So that book is optional, and it's just that it kind of closely follows the material that's there in these chapters. Okay, although the number of chapters is greater than the number of lectures, depending on how much ground we cover, we may be able to pick up all the modules, or we'll drop some if there's an overlap. For example, the big data part has an overlap with Spark has an overlap with the big data course, so maybe we'll skip that. We'll see. So let's come back to chapter 1. So today we'll look at basics, setting up Python, setting up Jupyter, but on a remote machine, on a server, secure it. That's, I guess, an optional thing. And then, I mean, optional for us, but very important in production settings. And then the kind of key hopefully milestone that we want to reach is simple Flask based web server which can serve a machine learning model, where what you do is make a request, hey, here's a feature vector, tell me prediction, and hopefully that server sitting somewhere on maybe in Washington DC or Seattle can respond back and say, hey, here's a prediction. Okay, so that's the learning goal for today. But let me continue with the logistics. So as I said, there's a slide deck that I've opened, and I'll go to that next, which covers, which gives you a high-level journey, high-level idea of what journey we're going to take. Okay, and that's because this is a course which is constantly evolving. The tools and the services, for example, we're going to use AWS and Google Cloud in this course, and even the services that they provide, for example, storage service S3. Its feature set may change from last month to next month. Okay, so things can change, but the underlying patterns and core ideas are kind of stagnant, are fixed. So anyway, the deck kind of gives you a sense of like what is the trajectory of the MLOps course in addition to this list of chapters. There are example implementations. They don't correspond to exactly chapters, but they do correspond to concepts. And we'll try to use actually one of, we'll use this link here to look at some example web server plus machine learning models today. Okay. Sorry about, there are some grammatical mistakes. I'll fix them. But so this second link is the one which you will extensively use if you want to try out something. Okay. I have repeated twice saying that this is a semi-hands-on and more practice-oriented course. So if not this lecture, next lecture onwards, you should try to clone this repository and try things either beforehand, during the lecture, or after the lecture, immediately after the lecture. Okay, so that's how you learn and get exposed to the ideas presented here. Otherwise, it's going to look like a very abstract, or not abstract, but very not grounded in reality type of a course. And that's because you have to do something hands-on. Okay, there's no way around it. You can't just listen to, hey, this is how AWS works, or this is how Docker works, and learn it. Okay, there's no way around it. So you have to do something hands-on. And please make use of the TA as well as myself. We have office hours, and you can also email us and figure out and ask questions. And because in particular, the project component will compel you to do this at least. Okay. For sure. So there's one component to this course which is going to be evaluated. There are no graded assignments or exams. It's only it's only 7 weeks, 6 weeks actually effectively, with the last lecture being presentations by student groups. So you have to form groups of 2. Okay, strictly less than or equal to 2. There is a spreadsheet linked here that you can use to, once you have formed a group, you can put your group a pair of names there. If you've not formed the groups yet, you can put your names in some rows, some cells which have been reserved for people who are looking for groups, and you can find groups find other students that way. You can also use other channels, beyond what I'm showing here. Try to form a group soon. Although there's no strict deadline, there is. Because it's only an 8-week-ish situation here, so you do want to have a group soon so that you can actually do a good job with the project component. Okay, so the project component is a big chunk of this course, and the criteria for evaluation is listed in the project page. It's mostly how correct you are in executing whatever you're doing, how what's the content, and you can always check with us whether a project is too ambitious or too simple, or any other concerns you have, and also, for example, the clarity of exposition of how you've documented your project, and novelty if there is any. Okay, so look at the project page for some recommendations on how you want to architect your project. Okay, and that, just think of that as a running long-term assignment. Okay, that you have to get started soon, or at least start editing soon, and talk to the TA and myself, so that you're not doing something last minute. Okay, So any questions about the logistics before I get into the slide deck and give you a sense of the material?
Yeah, Professor, about the project, will you give us like guidelines what to like
Yeah.
which models to implement or something, or that is up to us, like whatever we can do?
Yeah, so the model choice itself is not important. So there have been very interesting projects. For example, last semester, projects have ranged from, so many students, they either have some domain expertise, like in healthcare and finance or something else, or they might have done some modeling in 572 or 575. They generally pick up the same model and they tend to deploy if they're focused on a deployment focused project. So if you're, since everybody has different comfort levels in terms of like what should be the scope of this project, if you're really unsure of like what model to pick, you can always email me or we can have a Zoom session offline and we can discuss. Okay.
Okay.
So,
Thank you.
but in general, it's safe to pick any model because the model is not the important component. It's like trying out these other things which are relatively hard, relatively new for some of you, and so that will be where the interesting thing lies. Yeah.
Okay. Thank you, Professor.
Yeah. So I think the project page also emphasizes that. So I encourage all of you to look at the project page, the link here. Okay. Any other questions about the project?
Professor, is there any chance we can have a group of 3 students?
So the group choice has been made based on the number of slots and so on. I think it's a case-by-case basis, I would say. See, these suggestions are only because that's the optimal for you to learn something. Okay, so I think there is actually a component where, yeah, so 3 could be fine. Okay, it's not a hard no, but it's really important. The project could be like a 3-person project versus a 2-person project. Of course, there's going to be more resource hours or whatever, put into a 3-person project. At the same time, each person will also be evaluated based on how well they support the group. Okay, so either so it could be a 3-person project, but everybody has to contribute.
Okay, thank you.
But yeah, I think just email me. I think currently the spreadsheet is for 2. So, but if there is really a need for that, then we can accommodate that. Yeah. Okay, so let's actually get into the detail. So get into the some detail of understanding what MLOps is about, because MLOps can mean many different things. By the way, this slide is linked on the syllabus page as well. I think there's a slide link right at the top here. Sorry, it's at the, yeah. So this, I'll keep updating it, slight variations, slight improvements so that the narrative makes sense. But I want to spend some time on this because many students might have signed up for MLOps without really, without really knowing like what's kind of expected and what is that they will learn. Okay, so what are the learning goals? Although the learning goals are there per chapter in the syllabus page itself, like here, right? Each one has its own learning goals, but they are a little bit myopic, right? So they are in the sense that they're specific to the chapter of accomplishing X, Y, and Z. But the overall goal of MLOps is to really familiarize yourself with what does it take to go from a student of a machine learning in a university to a professional ML personnel in a team, okay? In a team in the industry, in the tech industry or elsewhere. Machine learning models are being productionized every day. Okay, so all the popular services that you're aware of, like Facebook, Instagram, Netflix, Spotify, Siri, Alexa, whatever service you think of, and also these Google search to any other tech product, not just tech, but also on the healthcare side. Fraud prediction or mortality prediction or anything else, all these models, you would have built maybe a simpler version of them or some variant using offline data as a part of your assignment or as a project for a course or something like that. But there's a few more things, moving parts that you need to kind of consider when it's actually is important where it's actually meeting the reality, okay, which is that it has to be used by users, and they expect it to be maybe scalable, maybe low latency, maybe very reliable, should not error out, maybe should be easily accessible, maybe should be behind authentication system. So there are many things that will come up, right? And you as a one data scientist or one business analyst, you cannot do maybe 10-20 years ago you couldn't have done all these productionization aspects, but today in 2022 a lot of these service providers have come up, as well as software packages have come up, which lets even a single business analyst or a data scientist to be able to at least scaffold a version 1 of a production ready system, okay, whether it's for retraining a model periodically or whether it's serving a model through a web server, okay, or something else. So because the tools are available, even one person can automate. So this is like getting, instead of having a dedicated team for productionizing, you can get away with a single data scientist or a single business analyst, okay. And the effort needed is actually not much more complicated than training a model. Okay, so all the nuances that you went through, training a model diagnostics and things like that, very similar level of understanding is needed, or even less is needed to kind of use these tools. Okay. All of the tools are evolving these days. As I said, every month the underlying feature set kind of changes, like evolves and so on as they mature. But the ideas remain the same, and the ideas are outlined here. Okay, so and the purpose of MLOps is to really do that survey. Okay, it's not a broad survey, it's not an extensive, comprehensive survey, and your mindset while approaching this course has to be like a lab student. Okay, so this is a hands-on course. You will learn the most if you do if you use that code link that I showed you, and I'm going to show you later on this session as well. If you clone it, if you get the code, run it locally on your machine or elsewhere, and debug it and try it and so on. Okay, that's how you learn. Otherwise, it's going to be it's not going to be effective at all. Okay, and you will not learn anything from this course. So come with that mindset that it has to be practical. You have to do, it's like a hands-on session each week. Okay, so with the disclaimer that it's not broad, so let's look at what are the narrow few topics that we look at. Okay, so the first set of topics, as I said, is related to batch machine learning. Okay, batch machine learning is something what you've been doing, in 575, 572, big data also potentially, which is mostly you have a batch of data. So as the name implies, there's a batch of data which you have used to build a model. Okay, so it's like literally supervised learning on your local machine or somewhere else, on Google Colab, for example. You got this model, and then you want to use this model for inference. Okay, so the act of you sending a feature vector and getting a prediction is basically inference, right? So there are various ways to set up an inference system. Okay, the first version that we look at today is a hosted approach. Okay, a hosted approach just means that you are the one who's gonna spin up a machine, set up all the basic things, and then install Python, and then maybe here we're going to assume mostly Python-based tooling. So install Python and then install the necessary packages, and then spin up a Python-based let's say web server and do it, and then host your model so that people can do inference. Okay, so that's hosted. Okay, you're doing everything, except for maybe renting a machine itself, either in your office or maybe on the cloud or wherever. Okay. As opposed to that, there's going to be two other approaches. Okay, and these two other approaches are actually managed approaches. Okay. On the extreme end to this web server-based approach, or the hosted approach, is going to be a serverless architecture. Okay. Although the name means serverless, there is still a server involved. It's just that you don't get exposed to it. You're only concerned with the correctness of your function. Okay, just think at the level of, in your Python script, there's a function which says, hey, model.predict X, right? So as long as you can get that function correct, everything else is taken care of by the vendor who provides the serverless service. Okay, in particular, we'll look at Google functions and then AWS Lambda functions. So Google Cloud Functions and AWS Lambda Functions. And so those are the extreme other end, where the only thing you care about is that your prediction function and nothing else, which is complete contrast with web servers, where you don't not just care about your model and the wrap Python code, but also the whole system. Okay. Somewhere in between these two extremes is the containerization idea. Okay, so containerization idea using Docker or whatever is where you have a Python script which can, given a feature vector, can spit out a class prediction or whatever. You're gonna wrap it up around, basically imagine a container, like a box, right? You put your function inside a box, and that box is going to be shipped to either a cloud provider or to your local machine. And the local machine and the cloud provider don't need to be very concerned with any other supporting packages that are needed. The box itself will have a Python script and the supporting packages typically. And so it's very portable. Okay. And so you can do it using a managed approach. So once you do this containerization, you can go back to a web server and put it on a web server. Okay. Or you can go to the cloud and put it on the cloud. Okay. The cloud vendors not just give serverless services, they also rent machines, so you can put it on the cloud. And you can also manage them, manage this container, and not just one container. If you have, let's say, 10 containers, one is a machine learning inference container, one is a database container, another is a regular HTTP web server for serving like your marketing pages or blog pages. So all these containers can be considered together in a what is called a container management system, like Kubernetes. Okay, and as I said, the managed cloud vendors, in this case, here are the two names. AWS has something called Elastic Container Service, and Google has something called Google Kubernetes Engine. These are just managed vendors who kind of make you, allow you to kind of not worry too much about behind the scenes what's happening on the individual computer, okay, that you've rented or on your which is in your office. Okay, so anyway, so these are the three kind of approaches. As I said, one end is you doing everything, not just your model, but everything else on that machine. And the other end is serverless, where you only care about your function, which maybe wraps around your model or predict call, but nothing else. And in between, there's this containerization business where you just have your script and some supporting packages like NumPy, SciPy, and so on. But everything else is taken care of by either like a vendor like Amazon, or you may have to like install Docker on an individual machine. Okay, so those are the three parts. Okay, and this is where we'll spend the first two lectures. After that, okay, we'll switch. So this itself is going to accomplish one goal, okay, which is to get familiarized with these tools beyond inside Python, you might have learned how to use pandas, you might have learned how to use NumPy and so on. But outside Python, okay, for example, you may need to know some Unix tools. Okay, for example, cd command to change directories, ls to list files, okay, cp to copy things, ssh, which will be a big part today, is to how to connect to another machine and get to a terminal command prompt and so on. Okay. So there's other commands that you'll have to learn, and so that's where some new things that you'll have to kind of get used to. So that's serving a machine learning model using very simple ideas. Okay, there are many other things that you could do, but at least bare bones, this is what we'll cover. The next topic is going to be model retraining, versioning, and testing. Okay, so this is where I said, so you may be getting new data every week, every day, for example. Think of, let's say you're making a crypto trading bot, okay? And so then you have to get new data, new prices and new volumes and new information from the exchanges. And so you get new data. Maybe that new data will be used to retrain or update your model. Maybe the model weights have to be updated, okay? And that has to happen in a periodic manner. And so you will have to do what is called scheduling. Okay, so schedule your activity, which is your training activity, to occur in periodic times. Okay, so there are a couple of tools, something called cron and something called airflow. Okay, so these are tools that we'll see eventually later, but there are ways to schedule this model retraining process. There's also tools to version the model. So every time you run, it logs, hey, this is what the parameters, this is the amount of time it took, this is the accuracy, and so on. So there are some automated tools to do that, so that you don't have to keep track of, hey, model underscore version 1, model underscore version 2 .py. You don't have to do messy ways to do it. So there's some nice tools that have come up to help you version your models. Also to version your data. And then the last part is testing. So as I said, if you are in a team, in a machine learning or data science team, and you want to, let's say, working for Netflix, and you want to come up with a new recommendation system that offline you show high precision, high recall, high F1 score, high normalized discounted cumulative gain, whatever metrics you show, and say, hey, my model works better. But the stakeholders, the business folks, are not going to agree, right? You will have to actually do an A/B test where maybe 50% of the population sees the old model and 50% of the population sees the new model, and then you actually see how much movies were watched depending on the model, or how much engagement users had based on the model, and that is basically an actual live randomized control trial. Okay, so that's what I mean by testing here. And there are other testing aspects also, but that's what I mean here. And so that's the second bullet point. The last one, so the third one is distributed data processing. I think some of you, I don't know if you've already taken big data, but it's basically about when the scale of the data is such that it cannot fit into your RAM. Okay, so for example, if you do pandas.read CSV and the CSV file is like 30 gigs and your RAM only has 8 gigs, then of course it'll fail. There's going to be an out of memory error, right? So how do you deal with data that's bigger than a single machine can fit? One natural extension is to, of course, go to multiple machines, and that's the direction that we're taking here. Of course, there are other ways to deal with large data. For example, you can literally just subsample the data so that it fits in your memory, or there are some lazy loading ideas-based solutions, okay, that you can also use, like Dask and so on. But if the moment you go to multiple machines, there has to be some behind-the-scenes glue code which orchestrates, hey, if you want to compute the average of a column in your table, then if the data is split across 3 machines, then there has to be an average on the first machine, average on the second machine, average on the third machine, and then again an average somewhere else, right? On, let's say, on some driver machine. So that's all behind the scenes, accomplished using Spark is one such solution. There are many other solutions like that. And so we'll look at that briefly. And there's a managed service provider called Databricks, which provides a hosted version of a Spark cluster that you can, kind of spin up and do this. So we'll look at that. And the last part is streaming. Okay, so streaming setups. Okay, streaming setups in production systems are about the example that I gave earlier, right? So if your machine learning model, let's say the part 1, okay, can make a prediction, takes 10 seconds to make a prediction. Let's say for very toy example, let's say it takes 10 seconds. So the moment you give a feature vector, it takes 10 seconds of computation to produce a class. Okay, but maybe you're making predictions. You're making these predictions at the rate of 10 seconds per prediction. But then you have, let's say, 100 smartphone users who have all installed your app, and the apps are all sending requests for making predictions. Okay, at the rate of maybe like 2 predictions per second. Okay, so now you have a huge mismatch, right? 2 predictions per second are being requested, but you can only make 1 prediction every 10 seconds. Okay, so how do you deal with this mismatch? Of course, there has to be some notion of a buffer and some sort of a, get all these requests and slowly process it, or parallelize the processing so that you can have instantiate multiple of your model instances so that they can, each one can work on, maybe if you instantiate 20 of them, then they can go at 2 predictions per second or something like that. So there are those considerations that you can do. And so that point of view kind of doesn't think of data at rest, as in doesn't think of a batch process, as if you're doing pandas.read CSV or something like that, or select start from column or something like that. It's not, select start from table or something like that. It's not going to be a batch type of an approach. It's going to be send a feature request and get a feature and make a prediction. So it's going to be some sort of a what's called a pub sub, or publisher subscriber, or a publisher consumer architecture. Okay, so we'll look at that. Okay, so one example of that is one open source implementation of that is called Apache Kafka, and we'll have a look at that. And by the way, all these are time permitting. So if we spend more time on one, then maybe we won't have time on the others, but that's fine. So this is the bunch of topics that we look at in this course. So now, some of this may be super new to you, but how are you guys feeling about what I'm trying to say about this course? I mean, as I said, it's practice oriented. You have to kind of do things hands-on. You will be learning a little bit of Unix, sorry, not Unix, but some command line tools, okay, like ls, cd, and so on, ssh. Okay, it's not necessary. You can always skip it and just listen to this, but it's not going to be effective at all. Okay. With that, any questions from folks? Okay, if there are no questions, then let's get into batch machine learning. So I just use batch as a name because once you deploy this model, the server will keep, when we say deploy the model will be kind of, in memory, and the Python script will be running. Okay, it's like it hasn't terminated, and it's gonna anticipate an input and produce the prediction and send it back. But the model is fixed, so it's like it might have been trained using a batch of data, and it's there. Okay, unless you terminate and recompute the model and switch it over, it's going to be there. Okay, and that's what I mean by batch ML model. Okay. So let's actually look at a couple of slides and then go over to our notes and actually get something hands-on. So at the high level, okay, this is not very specific to any. It's not specific to our ML model deployment, or it's like serving an ML model. This is true for any website that you visit. For example, even this GitHub page that you've opened, like I have opened several here, like the syllabus page I've opened. So what happened, right? So when I opened the syllabus page, this page, so I went to this URL, right? So I made a request to a server, which GitHub has. Okay, so GitHub has a server, and I'm the client. My web browser is the client, and I send some request. Hey, give me this data, right? And GitHub in this case is getting the request. Okay, and that's why is getting the request. So that's this arrow towards left to right. Okay, and it's saying, hey, Teja is one account, and MLOps, whatever notebooks, is one specific repository in their huge set of repositories and huge sets of users that they have. They'll go back and find what page I've requested, and then send it back. Okay, and this arrow to the left and to the right goes over the internet, right? So through your internet service provider, through other intermediate machines, and so on, and eventually reaches GitHub's machines, which is the server, and then they send it back, and that also hops through several intermediate locations and eventually comes back to my browser. Okay, and of course this process requires the request knowing where it wants to head to and where the response needs to come to. Okay, of course, but if you ignore that aspect of keeping track of where to go and where to come back, the client makes a request and gets back in this case a web page. Okay, and so one of the ways to do it is using a web browser, and that's what we typically do. In the class, we'll use Python to make such requests because we want to make requests using a feature vector. We can use Python. We can also use a web browser. We'll see later today. We can also use some command line tools. Okay, one of the tools is called curl, C-U-R-L. Okay. So in fact, let me. So this is the command line. Okay, so you can see there is some prompt here, and I've typed some command. By the way, I'll come to how I got to this, a little bit later. But this is just a Jupyter instance. I think some of you might have already used this for several of your assignments in other courses. Okay, that was a long printout of what all you can do with curl. So curl is one command line tool to talk to different servers. Okay, so curl, Python-based approaches, and web browser-based approaches. They're all ways to send requests to different servers. Okay? And their servers need not be just our machine learning inference servers. Now, the server itself. Okay, so where is the server? Okay. So here I've listed a few names. So EC2 is what we will try to see today. Okay, EC2 is a rent a computer service by AWS. Okay, and we'll work on that today. VirtualBox is a way to run a virtualized, virtualized computer in your computer. So, okay, maybe some of you are using Mac, some of you are using Windows, maybe some of you are using Linux. So, but irrespective of the operating system that you have, you can always run another isolated operating system in your operating system. Okay, and that is possible, using software such as VirtualBox. Okay, you can use EC2, VirtualBox, or any remotely managed machine. Okay, so EC2 is just one example of one vendor, AWS, but there are many vendors that all do. They can, who all allow you to rent computers from them. You can also have machines. Maybe you have two machines. The second laptop or the second desktop you have can be a server, and so on. Okay, so it could be anything, any other machine. Any questions about this high-level architecture? Because we'll get into some details about setting up, as I said, we're going to get into details about some command line tools to get our web server set up and get our Python installation set up. Okay, so let me discuss some tools. As I said, we will not use all of them today, but we'll see some of them today, and I'll explain kind of their use and some minimum usage as we go. So as I said, to rent a machine, you can rent it from either AWS or GCP, or there are many other vendors. But here I've just listed two. You can also, if you don't want to run a machine, let's say you don't have an AWS account or a Google Cloud account, then you can use also VirtualBox. Okay, and I'll show you how to use it. So VirtualBox, as I said, is a virtualization software so that you can run any operating system, many copies, many multiple machines on the same machine on your own laptop or desktop or whatever. The second tool, and there are actually other tools, but I'm just listing a few, is called SSH. So it's a way to connect to these servers. Okay. So earlier I said clients can connect to servers using what I showed over here, these arrows correspond to a protocol. Okay, protocol just means a procedure. Okay. What I've shown here is what is called the hypertext transport protocol, okay, HTTP protocol. There are many other ways for clients to talk to servers and servers to talk to clients. That one way is using SSH. Okay, SSH is another way to communicate another way of communication between a client and a server. Okay. There are other ways like using WebSockets, using some other protocols and so on. So for example, if you're using WhatsApp, then that's using some protocol to connect to WhatsApp servers. If you're using, let's say, some other messaging software, for example, it may use something else, right? So, but we look at SSH because it's a very elementary and very useful, nice tool to use to log into machines. And then, of course, we need Python. So I hope everybody is familiar with Python. If not, please let the teaching staff know. It's a kind of a prerequisite to have working knowledge with Python. Learning Python and this course is not useful because it's already a very short course. So in Python, we'll be using JupyterLab, and this was a kind of a run of a JupyterLab. We'll also use, occasionally we'll use pandas and some other software. Mostly it's just set up our model. Okay, so we need to have model somewhere. For example, we could also work with scikit-learn, right? For those who have used scikit-learn, there are some other helper packages like Pickle. Pickle is a way to serialize Python objects. So serialize just means if you have a Python dictionary, for example, you want to write it to a file. Okay. You can, of course, always write key value in a CSV file type of thing and write it as a text file. But you can also write it in a more native format to Python, which is called a pickle file. Okay. So, for example, if you have an object, sometimes it's serializable as long as it doesn't have very complicated things in there. For example, a Python object, which is an instance of a Python class, if it just has a bunch of numeric variables and then string variables and then a dictionary or a list or something, it's easy to serialize using pickle package. Okay. Request is a library which is used to do this. Which is used to make these requests. Okay, request is a nice library that's available in Python to make get and post requests to servers. Okay. There's a difference between get and post. I didn't explain it earlier. Get request is to get a web page, like how we got this syllabus page from GitHub. A post request is when you're posting information. Like, for example, you're sending your username password to a server to authenticate, or when you're filling up a form and saying, hey, today I'm not available, or today I'm available, or something, some form information, then you want to send it to a server. We'll need to do a post request when we want to send a feature vector to a ML inference server so that it can give us a prediction back. We can also use a get request. So we'll see both in our examples today. And yeah.
Professor?
Yeah.
Yeah, we are using Jupyter Lab here, but we cannot use Google Colab, something like that.
You could use Google Colab, and we'll see where it may not be used. So here it's really, certainly you can use Colab. Colab is a managed service, managed by Google, and so you don't have to worry about spinning up something. There'll be some parts where you may not want to use Google Colab, but if you want to just make requests to a web server, like you can always use Google Colab. Yeah. So we'll see where Google Colab may not be appropriate. I'll mention it.
Okay, thank you.
And finally, Flask. Okay, so Flask is not something that you would use Google Colab for example. Flask, typically you write a file name.py, like a standalone Python file, and then run it using Python space file name.py, and then it will keep running in the background. Okay, or maybe in the foreground, wherever it is, but it's going to keep running and waiting for requests to come so that it can serve back a prediction. Okay, so we'll look at Flask today. Flask is just one package, by the way. There are many other packages, competitor packages that some of you probably are aware of already. But for us, for a minimum working example of how to deploy a model for others to consume, it's a good starting point. Okay. So here I wrote CLI. Okay, CLI stands for command line interface. Okay, so it's a bunch of commands. I think some of you have used DOS. Or like a CMD command, you would have tried, or PowerShell in Windows, or maybe in Mac, you've used Terminal or Item2 or things like that. Would have seen this. And in fact, that's exactly this here. I used this is the command prompt. Okay, and you can use, for example, like I have a bunch of folders here. You can also get at least 2 of these folders. It's these 2 folders, because these 2 are on GitHub for you to get it. So there are a bunch of commands. Okay, ls, cd, sudo. Sudo is a command that's used in let's say Ubuntu or Debian-based systems to get yourself administrative access. Okay, it's basically like a super user. Okay, so and there's some specific Linux-based commands. We'll look at them later. Curl, I just mentioned, is a way to do that get request or post request, very similar to how a web browser makes a request. Hey, GitHub, send me this page. Very similar to that. Curl can also make that request. We'll also see SSH-related commands, SSH itself, and SSH keygen, and so on. Yeah, and we'll also see a few other things, auxiliary things. But today's lecture, although there'll be a bunch of new commands for some of you, as I said, it's not to scare you off or anything. It's just giving a sense of like what goes behind the scenes to set up like a production. It's not exactly fully production ready, but getting towards a production ready, productionizing your machine learning model. Okay, so it's a good toolkit to kind of gradually learn as you grow in your careers. So any questions at this point?
So Professor, I had one question. When you talked about SSH, you also mentioned the HTTP. So is it like an alternative to HTTP, or?
No, HTTP is exactly what we're doing in the browser. SSH is a slightly different protocol. It's not an alternative because SSH serves a different purpose than what HTTP does. Okay, so HTTP is where all the modern internet runs. Okay, at least public-facing internet. SSH is it's like a command line version of remote desktop. Okay, it's for you to log into another machine to do other things.
Okay, but you would still do like a get or post from SSH.
No, not get or post. It's like a remote desktop. So you enter your username, password, and you can get into another machine. In particular, we'll try to get into the server machine.
Okay, got it.
Yeah. And then, it's like remote desktop, right? Remote desktop, if you use Microsoft Remote Desktop or one of these BNC or any of these remote desktop clients, you enter your username, password, but then it kind of starts rendering that desktop from whatever that remote machine is, right? So behind the scenes, how is it communicating to the machine and sending the screenshots or whatever, right? So it's like that, but it's not a graphical version, it's a command line version. So after you SSH, what you'll get is still something like this, okay? But you'll just see, instead of Teja at some local machine, it'll be Teja at some AWS EC2 machine or something like that. So that you are executing commands on that server rather than local.
Got it. Thanks.
Good. So let's come back to any other questions?
Yeah. Do we have to use Ubuntu or can we use like Arch?
The choice, I mean, for this course, I would suggest use Ubuntu is the recommendation. You can use anything else outside, or if you want to experimentally try things, you can do any other Linux machine. Yeah. I mean, you don't have to use, by the way, I mean, so the question was more about like, what's this Linux distribution you want to use? We haven't got into that. In fact, we'll see that when we rent a machine from AWS, we'll see some choices. And you'll see that most of the commands, at least the examples in this notes, bunch of notes, is kind of oriented towards Debian or Ubuntu-based systems. Okay, these are all just different types, different OSs with some commonality with other OSs, like what Chris mentioned. So I'll mention that when we get there. Okay. So the choice of this server operating system, that's what it is. So we'll get there, and I'll talk about it. Any other question? Okay, so actually this is what is called repository. So I don't know if so some of you may be familiar with GitHub and Git as a version control system itself. So that itself is also probably new to some of you. So this is just a folder at the end of the day. So this is a folder. You're viewing it through the browser because it's read-only. So you're just looking at, hey, there's a folder. Within the folder, there's a bunch of files. And you can see these all have an extension IPYNB. It just means it's an IPython notebook. Okay, so this is a folder which has a bunch of files. Okay, so you'll see that most of the material in the syllabus, each chapter or each module that you're talking about, they're all in these chapters. Okay, so and some of them have mistakes, and please let me know where the mistakes are so I can fix them. So these are all the chapters. Okay, so today we'll be looking at chapter 1. Okay, so most of the content will be going through these exercises. Okay, and that's where I said, the emphasis is really on hands-on, going through some instructions, discussing, and me demonstrating it. Hopefully, if you want to tag along, you can skip some parts and you can do some parts even live. Okay, or you can look at these notes before the class itself and try some things out beforehand. What you need for this is, so you have this GitHub repo, right? So what you could do is go to the green button and you can just always download it. Okay, but just downloading it is not going to be enough unless you have Jupyter Lab or Jupyter Notebook or some such thing that you can run on your local machine. Okay, or you can use Google Colab, as Taib was saying. So if you want to use Google Colab, you can always use this link and copy it in the Google Colab, and it'll open up this, and you'll be able to edit you'll be able to execute these notebooks. Okay, so many of these notebooks are not executable; they're just text actually, but some of them are executable. So you can do that. If you download it, you do need Jupyter Lab because all these are IPython notebooks. You can't just read it in a text file. Okay, so just be aware of that. So you can download it this way, or you can do. It says here, hey, first option is actually clone. There are only two options. Either you can clone this folder or repository, that's the word that we use, or you can download it. Okay, download it will just give the same folder. Okay, or you can clone, and clone, here's a link to the URL from which you can clone. Okay, so you can copy this, right, and I already have that, so I don't want to redo it, but let's actually, so mkdir is for one command line example. So it's just make directory. So I'm just going to create a temp directory and cd, change directory into the temp directory. And I can use git clone. And this command is, I don't know if it's by default available in Windows, but it's available in Mac and Mac terminal and what is the other one? Linux. So you can just paste it and press enter. Okay, so it's just gonna say, hey, I'm cloning that folder. It's taking some time, but after that, if you see that folder is there. Okay, so ls is a way to look at the contents of this directory. So if I do cd, change directory again into this and do ls, you will see all these chapters, notebook, and projects are there. Okay, or whatever, these files are there. And you can see on the right hand side, because I created the temp folder, it's there here. Double click on it. I have that folder that I just cloned. I can double click on it. These are chapters. I can go to chapter 1. Let's say I go to basics. So this is the text in that chapter. Okay. And actually, these are markdown cells, so that's why they're not code. But you get the idea. Any questions about getting this set of notebooks? Okay. On Windows, many of you have used Anaconda as the Python as a way to get Python as well as Jupyter Lab interface. You guys will also have this. Okay, in the sense that you can do file new. You'll have several options. One of them is a terminal. Okay, so since one of them is a terminal, you can get to the terminal. I haven't tested whether you have Git there. Yeah, I don't know whether you have Git there. If not, there are options. Okay, I think let me just open. Yeah, sorry, it's not here, but so there are some couple of alternative softwares that you can use. One is Cygwin, and the other one is called, let me just write it in a different tab. Cygwin or Git Bash will give you, and actually PowerShell also comes with these, or you can install these Git commands, the Git Clone command, for example. Okay, but Cygwin and Git Bash will give you the same, like you can use the same commands that I'm using. In PowerShell, there may be slight differences. Okay, so what commands am I talking about? Is just exactly this, right? So Git Clone something, right? Some URL that we used, right? This is one command. So the other commands I used were ls, cd, mkdir. So just commands to navigate through the terminal. You can always do that using GUI. You can go to a directory, create a right-click, new folder, and so on. But it's not always available, especially when you log into a server. So you kind of remotely connect a server. The server will not have a GUI typically. Okay, and so you will have to use a command line to create folders, manipulate files, delete files, move files, and so on. So that's where these helper commands make sense. Any questions? Oh yeah, so Chris says use VS Code. So yeah, you can use VS Code as well. VS Code is a it a full-fledged IDE? I'm not sure, but it's a nice text editor with the appropriate plugins that you can install. You can have nice code formatting, linting, type checking, all those things. Okay. Yeah, so I guess VS Code would be a good option. VS Code comes with a terminal. And you can also open IPython notebooks, as Chris is saying. Okay. And also,
Professor?
Yeah.
Yeah. Normally we, at least I have experience in like Anaconda Python notebooks. Like I'm still confused how to get this terminal. Sorry.
Okay.
Yes, this
so
is
if I
the
press, so do you get this default
uh
launcher?
Yeah.
So in launcher, ideally you should see a terminal at the bottom. If not, if you're on Windows and if you don't see it, then we'll have to debug it offline because I don't know exactly the details.
I think yeah, we need to look into this.
Yeah, so generally you should see terminal as one of the options in the other, I guess, part of this.
Okay.
Okay, so let's come back to, yeah. So today, today's outline, actually we spent quite a bit of time already, but today's outline is this, and I'll probably like spend less and more time as appropriate. Remember, the goal of today is really to just get a feel for, hey, how to do some bare bones setting up of a machine and then make our server model, right? So that's what we want to do. And so as long as we'll try to make progress towards that. Okay. So far we have not done anything. There is no server in the picture. We just our on client machine. I said we can have many of these things to just get to a terminal, right? A good solution is VS Code. If not, try Anaconda Python distribution. Or if you're already on Mac or Linux, then you don't have to do anything else. Yeah, so I'm going to just use GitHub, but as I said, if you have downloaded it, you can go to the chapter, double click, and you'll see the same thing. So there's no difference between this and this and this. So whatever you're seeing basics here and in the Jupyter, it's the same thing. So yeah, I'm gonna skim through this because it's still talking about why Python and some details like that. So far, in some of the other courses I've done, maybe 575 or 572, or maybe big data, or maybe deep learning. So you might have tried, you might have already got an experience with Python. You may already be a beginner with Python 400 course or something like that, and then you've already got an experience with Python. Okay. In general, Python is also somewhat dominant in productionizing machine learning as well. So in production, people really care about correctness of the code. There should not be any runtime errors. Code should be super reliable. All errors should be taken care of. And there should be very fast execution of the code. Python is not the best in all these directions. There are other things that you could do. But still, Python gives you, because when you do offline data analysis, whether it's exploratory or model building, you tend to use Python. So an ecosystem is developed where you can also use Python for doing things for productionizing. Okay. Yeah, so I guess so I'm going to go over this linearly, although I'm not using slides or anything, I'm just using this notes. But the objective is not to really spend time on each point, but to get a sense of, like a gist of what each subsection is talking about. Okay. So as I said, the objective is to get a basic machine setup, and that's these 3 points, and then making some requests. Okay, get a feel for how to make requests using Python, and then serve a model using Python. Okay, so that's kind of the 3-step process. And so first we're just saying, hey, Python is a great choice even for productionizing. There are many machines that we can pick up. Okay, many machines that we can pick up to set up our to deploy our machine learning model. Some of them, some of them are, I guess, some of them are not hosted, some of them are not managed. Okay, where they just rent you a bare bones machine. Like you can rent machines from all these providers here listed here, or you can use one of your local machine if you want. Maybe a desktop lying around, things like that, or your own laptop. Also, you can use VirtualBox. So here you need a little bit more skills, and that's what I'm talking about. So some command line skills and so on to be able to get your model deployed properly. Okay, but there are managed services, and that's where here are some names: Heroku, Azure, GCP, DigitalOcean, and so on. Okay, and really at this point, so today, although we're focusing on on-prem or basically hosted solutions, it could be also on the cloud, but really hosted solutions just mean you do a lot of the behind-the-scenes work. The decision between one versus the other is really depends on what skill set you have. Okay, so if you really want to be cost conscious, maybe doing everything by yourself is a good idea, because if you don't want to spend any, spend as little as possible. But if you're not skilled in these web, deployment or DevOps or whatever, DevSecOps, or these are all acronyms, but all these things related to productionizing services or models, then you can just use managed services. Okay? And it really depends on what is the need. Okay, if you're only trying to serve like 10 requests per day and it's only internal users, other team members in some other team in your company, then you don't really need a performant system, I guess, web server or model server. Whereas if hundreds of smartphone clients are trying to get predictions in real time for maybe based on your model, then you need a lot of engineering, okay? A lot of scale, a lot of non-functional requirements, okay, which are scalability, reliability, security, to name a few. I mean, there's others like maintainability and so on. In general, okay, for a business analyst or data scientist, it's going to be relatively hard to do local deployments or to do hosted deployments. Okay, so you need to know something about security, because all you've been given is a bare bones machine, like basically a fresh installation of, think of fresh installation of Windows or fresh installation of Linux, right? It's completely bare bones, and you want to expose it to maybe the public internet. Then you really care about other people not being able to log in and things like that. Okay, so you also care about reliability. Maybe you just want to back up. Maybe the machine crashes and you lose all your data. You don't want to have that to happen, right? So you want to set up some sort of backup or reliability or snapshotting aspect to this. And also you want to, you may not want to turn off your machine to update a model and then turn it back on. So there's some aspects to, there's some aspects that, maintenance work that you need to do, which may not be the best use of your time, okay, especially if you're a data scientist or a business analyst. At the same time, cloud deployments are also not easy, because the ecosystems are extremely complex these days. So AWS has like maybe 200, 300 plus services. They're launching a service every month probably. And so not just AWS, but all these other competitors as well. So once you there's a learning curve to any of these ecosystems, and unless you're using some really managed property of such ecosystems, it's not cost efficient to use them. Okay, so if you're using something agnostic to AWS and still using AWS, then it's not worth it. Okay, so you should get into an ecosystem or use a vendor if you really want to use some nice feature that they're offering. Okay, like maybe security or reliability or something like that. Okay, so Python development itself. Let's talk about the client. Can happen in text editors, right? You can use you can literally use Notepad++ if you want. You can use, as Chris was saying, you can use VS Code, PyCharm. We're not really going to do development here, so for demonstration purposes, we're just going to use Jupyter to kind of look at the Py files or the IPython notebooks. But you can use other vendors. Google Colab, is free access for non-commercial users. And there are also professional vendors for example, Spark ecosystem. So Spark plus Jupyter, right? So that's what Databricks as a vendor does. So you can use those things as well. So here in the notes, it says we'll use DigitalOcean, but we'll actually use AWS to set up a virtual machine right now. So what we'll do is get a machine, get access to it, as in, so we'll log in to that machine, not like a remote desktop, but through the terminal, okay, using this SSH protocol. Okay. Next, we'll set up basic firewall, but it's actually not needed for AWS machine, but I'll still show you how to set it up. Then we'll install Python. We can just use Conda. We can, generally, actually, we'll see, if we use, let's say, Ubuntu also comes with Python. If you just use Mac also comes with Python, but maybe those versions are older. And so maybe you may have to install a new version of Python. To have a long-running process, you want to have you want to run programs in what is called as a background program. Like it's always running behind the scenes, right? So even if you log off, for example, the program keeps running and is able to respond to requests. Okay, so you can do that. If you can set up a web server formally, but here we'll use a simple trick. It's using screen. You can also use some other things, but we'll use it to kind of make sure that our Jupyter server is running. Even if we close our laptop or turn off our laptop or something, or disconnect from Wi-Fi and so on. Okay. So let's get started with that. Actually, let's see, before we get started, let me also mention what we're going to do next after that. Yeah, I don't think we'll have time for this today, which is like a movie recommendation problem. So we'll just pick up an example from our repository. So let's see. Sorry, this is not the repository. Okay, let me go to syllabus. Yeah, so this is the code examples repository. So you can see there's a bunch of code here. So what we'll be focusing on are these few folders. Okay? So these few folders give examples of how to deploy models. So here's a image recognition model. Here's a simple non-machine learning related model. Here's a recommendation model. Here's a regression model, some weather prediction model, and so on. So there are like 5 different examples here. We'll try one of them. Okay. Yeah, so I think this description, we'll see, it may not be relevant, so I'm not going to discuss that at this point. But is this a walkthrough of this I guess, subsection clear? It's not much, it's just trying to motivate what's hosted versus what's managed, and there could be some pros and cons. Okay, and then some description of what we're going to do next. Okay, so actually, I didn't realize we took quite a bit of time. So we can actually take a break now and then resume at 7:30, and then we'll get started on hands-on part. So if some of you want to get set up, try to at least get access to a terminal so that you can, and if you have AWS, you can also log into it and be ready so that I can, I'll just use a GUI to set up a machine. So you can also do that. Okay. So let's take a break and let's resume at 7:40. Sorry, 7:30. Yeah. Okay, so welcome back. Yeah. So what I discussed right before the break is what I've written in steps. So what we're going to do now is a little bit more hands-on. So we'll try to get a machine, and this time we'll just try AWS. Previous iterations of this course, I've tried different things. You can do this instead of AWS EC2 machine. You can also try to get a Virtualbox with a virtual machine running, let's say Ubuntu instance. You can use DigitalOcean or any of these other vendors. You can also use Google Cloud Compute. So many options, but we'll just try AWS for simplicity. So there are only 4 steps. So when you get a machine, log into it, get into it. Okay, that's through SSH. And if you're not using AWS machine, you would also want to take care of security. AWS machine, there's some same default, so you don't have to worry about it too much. And then we'll get Python installed, and then serve the model. So what model? We'll just use one of the examples that we have. So we'll clone the repository and try to get that one of those Flask based serving scripts running, and we'll actually slightly pass through the script to understand what's going on as well. Okay, so I just logged into AWS. So you should be able to, once you create an account, you'll be seeing a very similar interface to this. So you can actually, as you can see, the number of services is like a lot. It's actually, so if you look at the service list here, I just, as you can see, I can scroll, I'm scrolling. Just for compute, there seems to be at least 10 different services. For storage, there seems to be at least 8 different services. So it's it's a pretty intuitive interface. It's just saying, hey, all these services we are providing, many of them are actually managed services, in the sense that behind the scenes, AWS is going to take care of a lot of things for you, even for compute as well. So we'll actually for today we'll not worry about all these other things. In fact, as a business analyst, as a data scientist, a good thing for you to spend time on is not the basic services in AWS, but actually the services related to AI or services related to data science. So I think, yeah, you can see in the analytics section, you can see a bunch of services here. Let's actually see. Business applications. Okay, somehow I'm not seeing, for example, SageMaker for some reason. I'm not able to eyeball it, but there are many solutions related to data science as well. So, but anyway, let's focus on EC2. Let's go to EC2. So we're going to create a simple service, so we're going to just rent a machine. Okay, so whether you rent a machine on AWS or whether locally you have another machine lying next to you and you want to set it up, as long as it says Ubuntu or Debian, it's all the same. Okay, so we'll just go to instances. You can go either way, and then we'll just let's click launch an instance, and then you can see the many. It's a simple flow for you to pick some instance with some same configuration. So by default, it chooses I guess Amazon Linux 2 AMI. I think we can go with that, or we can just pick Ubuntu whatever 2004 or 1804. These are just just like Windows 10, Windows 11. They're just versions of the software, version of the operating system. Okay, so it doesn't matter so much what you pick. So let's just pick Ubuntu. Okay. Okay, so if you have created an AWS account recently in the past 12 months, then you can actually get this, this machine for free for the first 12 months. Okay, so you can keep it running continuously for 12 months, and you should not typically incur any costs. Okay, I don't know if that's my case, but anyway, I'll just go with that machine. So you can see there's a huge list with all sorts of combinations. In fact, let me just point out for people who are interested in deep learning. For people who are interested in deep learning, these G4D and XLarge has 4 GPUs that you can use. Or P3. My God, it's a huge list here. Yeah. So P3 XLarge or P2 XLarge and so on. So those are ones which have GPUs in them. But anyway, let me just actually go to next. Okay, so number of instances 1. This is all just keep it default. There are actually many things that we're not going to discuss at all, in the session or in the course, like, hey, what's the network? What's a subnet? There are many details there, but since we have kind of time constraint, we'll only kind of pick the things that are kind of very essential for us. So okay, it's a bunch of options. We'll not look into that. What we will want to do is ideally increase the storage. Okay, so you can see by default the storage is only 8 GB of hard disk. Okay, so that is too low for us. So let's just change it to 28. Okay. Other than that, we'll the other AWS specific things, but we'll not worry about it. So before review and launch, you can see there's a configured security group. So doesn't matter. So there's some security group is just a AWS, I guess, way of securing your the machine that we are trying to rent. So it's saying, hey, you can currently, I'm going to set up this machine and I'm going to launch it. That's what AWS is saying, but it'll only let SSH using the underlying TCP protocol hit a port. Okay, port is like think of a physical port, right? I don't know if many of you have been to actual ports like LA port or any of these places. So ports are just places where goods come, right? Or containers come, or ships come, and then you can imagine a computer to be actually like a port where there are many entry points to talk to processes inside the computer. Okay, so and these entry points are numbered. Okay, so they're numbers, all the way from 1 to whatever, a pretty large number, like 100,000 or something. And so SSH protocol kind of uses a default port, which is number 22. Okay, so to go to a computer or go to a server, by default, you need to know something like an address to that server, and that's achieved by something like IPv4 address. It's a public address. We'll look at that address in a second. And the second thing is, even with that address, you can't directly talk to a program in that server. Okay, so you'll have to use a port where the program is listening. Okay, so port 22 is where on the server side there's an SSH server that's listening to incoming connections. Okay, so in our here, that I didn't mention the port, but there are two things to know to send a request. Of course, where to send a request, like github.com, and which port of github.com do I want to send a request to. By default, okay, so most HTTPS, most servers on the internet, like webs, like going to a web page and so on, the github.com or any other like google.com and so on, behind the scenes there's actually going to be an address. Okay, it's an IPv4, typically an IPv4 address, and we'll also get an address for us. And for HTTP based requests like this, get and post, the typical port is 80. Okay, and it generally is omitted. Okay, so it's a default port 80, or if it's secured connection, then it's 443 or something like that. But anyway, there's a default port that we talk to when we send a request. Okay, so we need to know the IP address and the port. Instead of IP address, you can also know like a typical canonical name like google.com or github.com or something like that. Okay, so let's come back here. So port 22 is open. We can add a rule. Okay, so let's since we are anyway launching it, so we can open port 5000. So 5000 is for is a port that I just want to open. Okay, so that's what I'm doing through this interface. This is just specific to AWS, and I want it accessible from any place. So from any place. Okay, so that's what, what is the source? Who all can address me? Okay, it's like if you are an email service, or if you are a physical, like to your door, you may say, hey, people from Massachusetts, they cannot send me an email. Okay, people from Massachusetts cannot send me an email. So those types of constraints, you can put it here. Okay, so it's just saying, hey, which IP address are allowed to even talk to me? Okay, so that's what this is. And so let's launch. So here it's aptly providing warnings that, hey, it's open to the world, everybody can speak to it, and so on. But for for temporary purposes, I think this is fine. And let's say launch. And so there's going to be an important step here, and don't skip it, folks, especially for AWS. So AWS doesn't let you log into this this machine that we're renting using username and password. Okay, it wants you to do use a more secure approach, and so it's going to give you what is a it's going to give you a key pair. Okay, so it's going to give you basically files. Okay, it's going to give you one file, but it's going to create one more file. So in general, so to start again, it creates two files. Okay, that's why it's called a key pair. So one file, it's going to keep it towards itself, as in it's going to keep it on the rented machine. One file, it's going to give it to us for our download right now. Okay, so those two files together help us establish a secure connection when we are trying to log into this machine. Okay, so we'll see how to use that key pair. So if this step was not there, let's say you're renting a machine from, let's say, DigitalOcean, or maybe there's a machine on your office or somewhere else, and once you VPN, maybe there's no key pair, you can probably generally like SSH with a username password. Okay, although that's not considered secure, and we'll see how to make it secure if there's time. So create a new key pair. Okay, so it doesn't matter, like there's some options. Keep them default. So AWS machine 22. Okay, so I just gave some name, and then download key pair. I'm just gonna save the file. And Okay, so that's only available only once, so you can't download it again. So it's super important that the file is there somewhere that you can access it. Okay, so let me check if I have it. Okay, so I have it. So I'm going to launch the instance, and I'm also going to move that key to okay. So this was the key that I got. So AWS machine 22. So that was what I downloaded from that interface. Okay, so let's see. So it's saying, it's running and so on. So let's actually go back to our interface. So you can see that the third column, it says pending. It's still, we're requesting the machine, and we'll set it up once we get it. Okay. And now for Windows users, working with that file that we downloaded is going to be hard. So let me write down some pieces of software. So there's something called PUTTY. Okay, so that's a way to, it's a client which can be used to connect to servers. Okay, so using SSH. Okay? On Windows machines, you can download this piece of software, and it can SSH into these remote machines. Okay, and give you a terminal. The problem is that file is not compatible directly with this, so there needs to be some conversion that needs to happen. Okay? I don't have time to do that in real time, but because I don't have a Windows machine at the moment. But for folks who want to do it, just ask me, and I can send you a link to how to convert that file into a slightly different file that can be used with PUTTY. Okay. Otherwise, we are good to go. Let's actually go back to. So now the instance is running. So let's see what the details are. Okay. So there's some instance ID. So actually, all this is very useful, and the reason why they give these types of things is you can actually programmatically create these, programmatically rent instances, programmatically, change access controls and so on. So there's a lot of flexibility that these big vendors do. Okay, and of course that's why they have really large clients, like maybe Netflix is a client for AWS, or US government is a client for AWS, or Zoom is a client for AWS, and so on. So, but they also serve, one-off people, like a data scientist or a business analyst. Okay, so here's the public IP address, and this is something that we will need, okay, for us. Since it's not running, it says it's running. Okay. Okay, so this is the public IP address, and this is what I meant by address. Okay, instead of github.com. So what happened with github.com is behind the scenes, there's actually an address like this. Okay, it's going to be a bunch of 4 numbers like this. It's just that we don't have a domain that we can kind of, it's like a dictionary lookup. Okay, so github.com should map to an address like this, okay? Or maybe many more addresses like this. But in our case, we don't have a kind of a canonical or English domain which we can map to this. So we'll just use directly the this IP address. Okay. There are other information here. Okay. So let's actually just copy this. I mean, I'm just going to skip back to where we were. So here is that PEM file. Okay. So let's try SSH -i. I don't know if this is correct, but let's see. I'm sure there's going to be a couple of errors now, but let's see what it says. Let's see. So first time you try it, okay, that IP, I haven't connected it before. Are you sure you want to connect? Let's say yes. So it says receive disconnect, too many authentication failures. So okay, let's actually let's actually try. Oh, okay. So I think I need to. I don't know if it's the right username. So is it called easy to user? I don't remember now. Okay, so what changed is there was a little bit of, so I have other SSH, I guess, key pairs. And so what it was trying to do was use those other key pairs to also try to log into this machine. So, okay, what changed? So I was trying, okay, this is not correct, by the way. So I was trying this command here. So this is another example. Okay, so very similar to, so you won't be able to use the same command, by the way, but let me just explain what's going on. So we got that file, remember? So two minutes ago, we got this file. It was in the appropriate directory. So that's why, it's in the same directory where I'm executing this command. That's why it's not looking for some other location. So -i means identity, like I want to use this particular key file to log into a machine. Okay, so the machine IP address, remember, we got it from the AWS website. And the default username is Ubuntu. Okay, so that's like something default. You don't have to change it. So I just had to add an extra -o, some command line argument. Okay, these are called command line arguments. -o something, -i something, and then some extra arguments, right? So, but the first command is SSH. Okay, that's the command line, just like very similar to CD or ls and so on. So what it's trying to say is that, hey, use these extra configuration options, but tell me, log in as user Ubuntu into this machine that you just rented. Okay, so this machine that we just rented. Okay, and so that's what we did. So you can see, welcome to Ubuntu and some other details. And then it says, hey, you're logged in. So this is not the same. You can see the prompt here is Ubuntu at some local IP address, which is different from my prompt here, which is my local machine, which is a data science step. Okay. So is this clear how I logged into an AWS machine? Okay, so this is, anybody else has any comments or something that I did not explain? Okay, so we got a machine, we SSH'd into it because by default, it all these vendors, they run an SSL server, when the machine is started. As I said, for AWS specifically, you can't log in with a user and password, but if that was not the case, if it was a different machine, let's say locally in your office, there's another machine that you started an SSL server on that side, then you can just use, so if you use the same type of a command, maybe even without a PM file, it'll just say, hey, what is the username? So what is the password? And if you enter the password, it'll log in. It'll get to the same location. Now, I said, okay, let's actually come back here. So Here are some instructions to add a new user if you want to, but we are not going to do that. Here are some commands to actually even install SSH server if you don't have a SSH server on the server side. Okay, but how do you install it? You need to have some way to access it, right? If you physically have access to it, then you can install SSH server like that. Okay. So there's also in this section, there's also some details on how do you create your own key pair if something like AWS doesn't provide one. So AWS provides this key, this key pair here or the key file, but instead of that, maybe some other vendor may not provide. Then there's a, hey, enter the password to log in, but you don't want to use a password-based login because other people can keep trying to guess the password and trying to log in. So instead of that, you want to disable password-based authentication and still use your own generated key file. And that's shown in this section, how to create that. Okay, so that the key command there is called ssh-keygen. It'll just create exactly the same thing that you saw in the interface. Hey, create a key pair. And using that, you can disable password authentication so that you can actually only log in if you have the key. Okay, and that's what we're already doing here. And so we're skipping these steps because AWS makes it easy for us already to not do this. But ideally, if you have a bare metal machine that you're renting from a data center or in your offices, in your local office network or so on, you may want to do this, okay, just to keep it more secure. So if you disable password authentication, then the only way anybody can get in, at least to SSH, is only if they have that key file, and that file is a very long file. It's not easy to guess, relatively speaking. As long as that file is not, somebody else doesn't get it, you're fine. Okay. Yeah, and the last bit is firewall. So there's a firewall called Universal Firewall, I guess, in Ubuntu-based systems that you can install. So it's just a way to disable or enable incoming and outgoing connections. Okay, so I'm not gonna meddle with that now, but you can actually just let's see if there's a firewall running there. Sudo ufw status. Okay. It's inactive. So actually that firewall is inactive. We can activate it. See. Oh, I don't want to try all this because I don't want to lose access in case it activates and disables my SSH connection. But you can set up the firewall as well. Okay, so I'll skip over that step because it's pretty easy. So you just need to figure out, like in our case, we just I believe. Okay, let me actually do it so that instead of explaining for 5 minutes, I can just do it in 2 minutes. Allow port 22. Okay, so allow 22 just means allow port 22. So it just says, okay, it's not even, it's not active. But okay, so what am I typing here, right? So there's a sudo followed by a command going on here. So this is not specific to this firewall business. So sudo is a command to get administrative access just to run that command. Okay, so it could be sudo something else. Okay, sudo add user Teja or sudo add user, Ubuntu user or something like that. So there are many commands that can follow sudo. Here we're just saying sudo followed by our firewall program and say, hey, what is your status? It says status is inactive. And so, hey, allow port 22 because that's how we log in. And it says, hey, rule updated. I typed something else. It said, it's not active. So what I need to do is enable, and it says it'll disrupt SSH existing SSH connections. I don't want to demo this right now, so I'll say no. But you can enable it. Ideally, since we allowed 22, it should work. But I want to move on to the next step. Okay, so which is what we did is talk a little bit about security. It's not really, we didn't really spend much time, a couple of minutes here. But UFW is a good starting option if you're going to run your own bare metal. So if you're going to rent a machine like this, where you have to do all this stuff, like, secure SSH login and then set up firewall or security. Okay, so these are some steps that I'm showing you that all this effort goes into just, eventually being able to serve a machine learning model, right? But these steps are kind of removed if you use a managed service. But behind the scenes, they are doing all this for you in a robust way, in a reliable way, and so on. Okay, so it's not magic behind the scenes, it's the same stuff. Okay, so now let's actually look at Python. So for that, so if you type Python at the interface, Python itself is not found. So let's see Python 3. So actually Python 3.6.9 is installed. Okay, so it's the default Python available in a default this OS. Okay, and similarly Mac OS, you will have a Python 3 or Python 2.7 or something like that already available. You can always install install Python again, and it in fact tells you how to install Python. Again, you can see sudo and then a particular keyword specific to this particular OS, Ubuntu/Debian. It's called apt. It's a way to install software. Okay, it's very similar to on Windows. You download an exe file and installer, and then double click using GUI. It's a kind of similar process. Okay, so since we have Python, actually, since we have Python, I think I can look into skipping it. But if not, if not, let me at least tell you what's going on in this section. So here we are trying to not install like Python the way it suggests in Ubuntu. What you can do is, it's very similar to how in Windows you would have installed using Anaconda, right? So Anaconda Python distribution, the full version will give you a bunch of, it'll install nicely, like you can double click on install, and then you'll get, icons where if you double click, you can get a Jupyter lab running or something like that, right? So, actually, what I'll do is run this because it's not complicated. So remember, all this is happening in the remote machine. Okay, there's a fresh machine, just has, maybe it doesn't even have the first command here. Okay, there's another command we're using here, which is called wget. So happens to be there, we downloaded it. Okay, so let me actually write it down. So we used sudo ufw whatever. We didn't use sudo apt, but it kind of, it showed, and then wget. Okay, so wget is just get a file from the internet. Okay. Okay, so we got the file. So if you look at ls, remember ls is again list the contents of this directory. It's a default directory somewhere. So this is the file that we just downloaded. Okay, it's miniconda instead of the full Anaconda version. So there's another command called chmod. So it's like change the mode of how I interact with this file. Okay, so it's like +x means make it executable. Otherwise, it's only read only. Okay, so +x miniconda is a command. So let me write it here. Okay, so that's the command we use. And let's come back here. So if I do again ls, you see that previously it was black, and now it's actually in green. Okay, green kind of says that, hey, this is executable. And the way you execute programs in Linux, very similar to, I don't know if you've tried it in DOS elsewhere, is like / the file name .exe or something like that. Okay, so I don't know if you've tried it in Windows or something like that. So here it's / file name .sh. So press enter. It says, hey, you want to proceed with the installation procedure. It's a textual based installation procedure. So let's just agree with the license and say, hey, do you accept? Yes, why not? And they're going to install it in some location. Okay, /home /ubuntu /miniconda. So if, for example, if you're on Mac OS, if you remember, there's /user /Teja or something, right? Or on Windows, it's I don't know if it's /users or something, but very similar, right? So it installed a bunch of some packages, and then do you want the installer to initialize miniconda? So you want to have it at the beginning. So let's say yes. Okay, so for changes take effect, close and reopen. Let's actually exit. Okay, now I've exited. This is my local machine. So you can see that I'm in MLOps folder in my local machine. Now again, let me log into that remote machine. Okay. Now you can see that there's an extra string that got added, and that's by this conda environment, so conda package manager that I've installed. Okay, so it has this notion of things called environments. Okay, so the default environment is called base environment. So think of environments as this self some isolated context switching. It's like multiple desktops. Okay, so it's like or multiple users. It's not the right analogy, but the base environment could have its own bunch of Python packages. The let's say data science environment could have its own bunch of packages. So for example, in my local machine, you can see that I have an environment called data science there. Okay, so it has all the data science related packages that I could be using. I could create an environment which is listed here. So for example, you can create an environment like data science environment with Python installed. Okay, so actually let's not worry about environments, but I would suggest look into this or Google online about environments. For us, since we are interested in getting to this step, which is we have Python installed, we want Jupyter so that we can remote access Jupyter and use that machine, remote access Jupyter, as well as run a Flask ML inference model there, right? So let's actually go back here. So it says install Jupyter and PyTorch and so on. So for now, I'm gonna pause on this. I'll come back to this in a second. What I want to do is directly deploy a Flask model. Okay, so let's do that and then come back to this Jupyter stuff. So Jupyter stuff will be important. For example, if you're on Windows machine or Mac machine, you don't want to keep restarting your Anaconda Jupyter and it's all local, right? So you can always run a Jupyter server on the remote machine and always keep it running. Okay, so no matter whether you're on a MacBook or in a lab website, sorry, in a lab machine at the university or somebody else's machine, you can always log into your Jupyter instance as long as you have your key file. Okay, and so we'll see that setup in a second. But for now, let's focus on now setting up Jupyter, but directly get to model, and then we'll get to Jupyter in a second. Okay, so is the sequence clear? What we're trying to do? Anybody has any questions? Okay, so if there are no questions, let's see. Let's actually get to a model and then we can talk about what else changed. I have been trying to log most of my commands. If I have missed something, please let me know. Some of them we have not used, but since you saw it in the interface, I just added it here. So let's actually now do this Git clone business. Okay, so we want our all these examples. We want to clone it. So let's copy this link that's shown here, and then go to our remote machine. This is the Amazon machine that I've just rented, and do Git clone, Shift Insert or whatever, Control B, and Git happens to be there. So it cloned that repository. So you can see that because now there are 2 files or 3 files. This was the original thing. When I did / this thing, it created a folder called Miniconda or Anaconda or whatever, so that we have Python there. And then now I just Git clone this folder. Okay, so mlops-code-examples. So let's go to mlops code examples, right? So all these are the folders with different examples. So let's actually go to Flask example, let's say regression. Okay, I don't know if we need a, yeah, so let's go to Flask example regression. So I don't think we have all the files. So let's actually see what is needed in regression. So let's actually now talk about deploying our model. So let's click on regression, right? So it's only a 25 or 30 line script, but let's understand what's going on. Okay, give me a second. Yeah, let me deploy it, and then I'm gonna cover some details. Okay. Yeah, so let me just walk through the script, and then I'm gonna cover some background material. So the first import is something called pickle. I hope most of you are familiar with pickling. I think at the beginning of the class I said pickle is a nice package to serialize Python objects. Okay, so it's a nice way to go beyond writing a text file like a CSV file or a regular .txt file. So if you have a dictionary, for example, you can put it onto a storage, saying, hey, this is dictionary dot, you can give any extension, so dictionary dot pickle, and then read that dictionary back very easily without creating a text file or CSV file. So important thing for us, the web framework will be Flask. From Flask, we are importing a few things. Okay, we'll talk about what these are in a minute. So what is this regression model? So a simple regression is just a regression in one dimension, right? So I'm going to give a one-dimensional input, a number, and it's going to produce a one-dimensional output, a number. Okay. So the model. So here's a very small helper function. Okay. It's going to take 2 parameter input, the slope and the intercept. Okay. It's taking slope and intercept, and it's giving me a linear model. Okay. So given the slope b and intercept a, for some reason, b is the slope and a is intercept, I'm going to create a function which takes a one-dimensional number, x as an input, multiplies it with a slope, and adds an intercept. Okay, so that's this function. I just defined this function. I'm just going to return that function. So this is a function that's returned. This is a function which is defining a function and returning that function. I just wanted to show you this because this is an example of function being first-class citizens. Okay, you can do function programming here. So a function is outputting a function. Okay, so let's look at the next few lines. Again, these are all just to set up. So the next line, so model params is
Professor.
Yeah.
Just can you explain that again? Like function being returned. This is something kind of new for me.
So in Python, you can always return anything like a dictionary, a list, or something like that, right?
Yeah.
You can also return a function.
It just basically it's going to return the value of the function. Like
no,
for example.
So whatever it returns, it's a function. So you can use the function. You can see it here, right? So so this get model. So let's see what's happening in line 11 to 13. Okay. So line 11 is saying pickle.load something. Okay. So load some data that was already created. Okay. And RB just means read and then byte mode or whatever. So there's some default choices. So we read the model parameters. Okay. What are the model parameters? They're only two numbers. Okay. We could have just saved it as a text file. Instead of that, we saved it as a pickle file here. So we read the 2 numbers. It's just, that's what these 2 numbers are. In fact, it's a list with the 0th entry being the slope and the first entry being the intercept. Okay. Now we're calling get model, which is defined in lines 5 to 8. Okay. With the slope and the intercept, right? So when I pass these 2, what is this get model returning? It's returning a function. Okay. That function, I'm calling it as model. Okay. Internally, it's being called line, but doesn't matter. So when I pass 2 numbers to this function get model, it's returning a function. I'm going to call it model. Okay. So now model is a function which takes any real number and produces this output. Okay. So if we want to simplify it, we can edit it, and so that we can remove all this function concept. Maybe we can do that in a second. Okay, so let's do that in a second. Okay, but I just want to explain forward. So if this is not clear to you, try to imagine Python functions which can return anything like lists, dictionaries, list of lists, or whatever. They can also return functions. Okay, Python functions themselves, which later, if they return a Python function, that can be saved in a variable, and that variable is called model. And it's that since the model variable is actually a function, it can take its own input and produce some output. Okay. The interesting part is this line 16 to 30, which are the bare minimum needed to be able to serve this regression model on the internet. Okay. So what is this doing? It's first creating an object of the type Flask or from the class Flask. Okay. So this is some default way to create an app, to create an object. Okay. We're just calling it as app because we're going to call app.run. Okay. So it's an object. Okay. So this object, has a lot of behind the scenes things going on. Okay. What it's doing for us, what is important for us to know is know that all these web frameworks, what they do is typically they will map a URL to a function. So think of, github.com/predict. Okay. That github.com/predict is a URL. When that URL is hit, when you hit enter that URL in the browser, the server knows what URL you are referring to, right? So that URL is using Flask is mapped to a function. a different function. Okay, so here it's saying, hey, map the slash root. Okay, instead of slash predict, just whatever without predict. Okay, website.com / map it to this function called predict. Okay, so that's the most important concept of Flask and many of these other web frameworks that you would see. It's just mapping a URL to a function. And once a URL is requested, you execute a function. Since you're executing a function, you know what to respond to. Okay, so that's what whatever function returns is the response. Okay, so here it's saying, hey, whenever somebody hits the base URL, like IP address, and that's it, no other extra stuff, then call this function. The function says, hey, is X in the arguments? So is X an extra parameter that was passed? And we'll see how to pass it. If X was passed, remember, X is like an input. Okay, so if X is passed, then try to return saying, hey, you passed X as an input, make a prediction and put it in a prediction. You can see that this is just dictionary, right? So with input being input itself and prediction being, I'm calling model with an input argument, which is that X. I'm just converting it into a float, okay? Because X is generally a string when it's read from a client. And that's it. Return this, and then an extra beautifying function called JSONify. We'll see that in a second in action. Else, if nothing is inputted, it'll say, hey, success false. The input X was not even given, or maybe not parsed correctly. Okay, that's all that's going on. So let's actually run it and then come back to maybe editing it and removing this function business. So let's see. So let me actually use another command. I'm using Vim. Okay, so Vim is a text editor. So I'm just going to edit this function. Okay, the same function that we read just now. Okay, so import pickle. So what I'm going to do is I don't even want to do this. I'm going to drop pickling. I just want to read. I'm going to delete this line. Actually, let me. So you can see line numbers, right? So I just removed pickling because I don't want to read it from some other location. I want to keep the example simple. So let me. I'm just going to call it a list with 1, 2. Let's say some numbers. It just wanted some numbers. So I just gave some. Instead of reading it from file, like ideally you want to fetch the model weights or model parameters from somewhere, right? So it's here. It's a very simple linear regression model. So there's nothing much to do. So it's just for demonstration's sake, I just set it to be some constants. Okay, and then some get model is happening, and all this is fine. So what I'm going to do is, okay, so I edited that file. So Vim has its own set of commands, WQ, insert. So there are many things to do here, and so let's not get distracted with that. How to work at editor, but let's come back. Now what we do is Python 3. Okay, actually this did not work. So switch Python. Okay, let's try that. So it says miniconda Python. So this is the Python that you want because this is the one we installed. Now I used another command. So let me write it here, which just means, hey, where is this executable? Where is the Python executable? Because we want the one which we installed, right? We don't want the system one. Okay, so now we can just say Python Flask simple regression service. You'll see that it'll fail because maybe some imports are not there. So Flask itself is not there. So let's say conda install Flask. Now what you can do is something called requirements.txt. Some of you might have used it, but you can predefine what needs to be installed and install all of them at the same time. So I said conda install something. Okay, that is very similar to pip install something. Okay, so it says it's of course installing Flask, but it's also updating many other things. Let's not worry about them. So let's say yes, and we got Flask installed. Let's run it again. So now you can see that it's saying serving Flask app, what is the file name, and then this is the development server. So this is do not use in production setting. Okay, so that makes sense. There's some extra production tweaks that you need to do, but we'll not go over them right now. So let's actually see. It's running on port 5000. I think it should be exposed to the internet. If not, we'll try to expose it to the internet. Okay, this is not exposed to the internet. Yeah, so I don't know if this is the right way to do it, but let's try. Huh. It's saying the internal port. Okay, let's see if that works. Okay. So what did we do? I ran the default file. It just didn't, it just didn't get exposed only because it's running on localhost. Okay, this IP address is for localhost, so it's not visible to the internet. So I just explicitly added some, like an explicit argument to the app.run statement saying, hey, expose it to the internet. And now I'm able to access it. So in fact, all of you can access it if you want to try it, but yeah, just to see, it doesn't do much, right? As you can see, if I open it, it says input was not passed correctly and it's false. So now how do we pass an input, right? So now we are using the browser, our client, our local machine, to connect to the machine that we just rented from AWS, which is running the simple regression model. And we asked a question, hey, we asked a question without saying anything, did not pass X, and therefore it said, hey, you did not even pass an X, right? So we can pass an X. One of the ways is the GET request that I was mentioning. So the way you do that is put a question mark and say X is equal to 10. Okay. So I just put it in the URL, okay, and then press enter, right? So it's saying input is 10, and so the prediction is 12, and that's because I guess 1 times 10 plus 2, okay, is 12, right? So you guys can try this. So just to get the extreme bare bones things running, and now let's come back to some fixes that you want to do. So Tayyab, do you still want me to kind of get rid of this and drop the function stuff?
I think it's fine. I think I understand it.
Yeah. I mean, there's nothing much going on. I mean, instead of this, you could have directly said model dot, you could, instead of this, I could have just said model underscore params bracket 0 times whatever X was passed plus, instead of all this extra function business.
Yeah.
Right. Yeah. Good. So that is good. So that's an example. So this itself, and now you can make things complicated, right? Instead of me reading a simple regression model like this and loading it, you can load a scikit-learn model. You can load a PyTorch-based model. You can load any model that you want. Any model from whatever you built from your batch training process. Okay. And the root need not be just slash, right? So this is what I was saying. The most important thing that the web framework is actually doing is pretty intuitive. It's just mapping a URL root to a function. Okay, so let's actually see how that works. So in fact, you can see the log of some people accessing it, probably. But let's see. Let's Control C. So instead of slash, let's say slash. So slash predict, right? So I'm running it again. And this time slash will not work because ideally it should not work. But yeah, it says, no resource found at that location. And now if I do slash predict and then question mark X is equal to 10, it should work. So it's just mapping that URL. I mean, you don't have to pass the original IP because that is by default. But from there onwards, you can do slash predict slash my interesting machine learning model slash, you can do 100 different slashes and then say what's the input. You can, that path will map to a function you care about. Okay. So any questions about this? Okay, if not, let's actually come back to some text. Yeah, so I wanted to show one last thing. So the text is actually just saying exactly what we have kind of experimented here. So, what is the purpose of model surveying? We know exactly what it is, share results with others, team members, and so on. How do we make a request and consume from prediction services? Okay, right now I just showed you a browser-based one. Okay, that's interesting, but that's not programmatic. That's like a manual choice, right? So actually, you can make requests programmatically. And a very simple way to do that, I think I mentioned curl at the beginning of the lecture. There is the simple approach, right? Using another package called requests. So let's actually copy this, and we don't care about the remote machine. So let's actually go back to so actually let's I'm just using my IP address, but instead of that, let's actually use the IP address that we have here. Yeah. So you import a package called requests and request.get, which is what we want to do. And we want to, and I hope folks know how to use f-strings. If not, it's a new feature in Python 3 or 3.8 or something. So here you can say what x is, right? Get the result with this. I think it probably makes it a string. If not, we can make it a string. Okay, so I just ran this code. I just passed whatever 4 inputs, 1, 2, 3, and 4, and it shows you what the response code is. Response code is a way for the server to say, hey, everything's processed fine. Here's a nice output. The response code is 404. I think we saw that earlier. That means something's wrong on your end or my end or whatever. So there's actually names. There's actually explicit descriptions for them. But here you can see return text is actually a JSON, is actually like a dictionary object, so that you can programmatically parse it. Okay, so input is 1, prediction is 3, 4, 5, and so on. Okay, so this is programmatic way of doing it. You can also do curl. So let me actually do curl right here. So in Jupyter, I think some of you know, you can actually do command line programs directly, right? So an exclamation mark followed by a command line program. You can use, you can actually even use pip install whatever Flask example. You can do these types of commands. Okay. So curl also, as expected, showed the right output. So these are the ways to programmatically or using other packages access your server. I think we are really running out of time. We did not set up Jupyter. Other than that, yeah, I think here's in this section, there's a different example, a weather reporting example, which is, instead of simple regression, what it's doing is you're calling for, hey, tell me the weather of Chicago. And then what that your Flask server is doing is ask another service behind the scenes in National Weather Service to tell it the weather of Chicago. And then once it gets back the response from that national, from US government's service, then it's relaying that back to you. Okay, so it's just an exercise in trying out how a simple, go to this route, either get or post is a little bit more, one step more than what we saw in simple regression. But it's a good exercise to not just go through this one, but go through all the 5 Flask examples here. Okay, so they're all related to this first chapter. So I strongly encourage you to try all of them. Most of them are ready-made, except for maybe a recommendation you need to create the model first. Even for regression, we had to create the model, but then I deleted that and just said, hey, model coefficients are 1 and 2. Instead of that, ideally want to create a model. And so that those model creation steps are in the model folders, okay, the bottom. So you see model example regression, model example recommendation. So there you'll see a PyTorch or a simple regression model creation process. Okay. Any questions about what we've covered today? If not, let me just recap very quickly the lecture goals. Okay, so that just so you understand like where we are. So today was just really a warm up. Okay, and I think I hopefully I gave you enough disclaimers that what we're doing is, ideally you know Python as a business analyst, as a data scientist. You just need to learn a few extra tools like this glue tools like CD, make directory, curl or whatever. And then use these managed services ideally. But today we did a little bit of more hard work, rented an actual machine where there was nothing installed. We installed Python and exposed port 5000, and therefore we were able to access the Flask server. But those are some steps that, were the goals today. So at least have a working Python environment. To be able to set up Jupyter session, we did not see today, but using screen, we will be able to set up Jupyter session maybe early next session. Securing a web server we have not done, except for it's already secure except for 2 ports, 22 and 5000 that are exposed to the internet. And then we were able to at least try out a simple Flask model. There are other 4 examples, but we have run out of time. So maybe we'll try it in other later on examples that we have. Okay, so when we try out something else like serverless technology or Docker or other things, we'll try out these other Flask examples. Okay. Any last minute questions? If not, what we can do is I'll stop recording and I'll just be online. But if folks have, and they can unmute themselves and say something. Let me stop recording. And thank you so much for everybody for your time.